Let's now discuss the inverse rule of natural logs. Since logarithmic and exponential functions are inverses of each other, then they can be used to simplify terms that contain one or both terms. So if two functions are inverses of each other, when they are applied to each other, they cancel each other out, leaving you with the original input value, which in this case is x. So f of the inverse of x is equal to just x. And if you switch the order of the functions, you still wind up with the original input value, which is x. So this applies to logarithms. Logs and exponentials are inverses of each other. So when you have a log of a base b, which matches the base of the exponential b to the power of x, the logarithm and the exponential cancel each other out, leaving you with the exponent x. And if you switch the order of the functions, and the exponential is first and the logarithm is second, they cancel each other out, leaving you with x here, the argument that is in the exponent. So if the base is e instead, the natural logs will cancel out just like regular logarithms. So a log of base e of e to the power of x, the log and this e cancel out, leaving us with the exponent x. And if we have e raised to the power of a log with base e, those cancel out, leaving us with x here. And a log of base e is the natural log. So the natural log of e to the power of x is equal to the exponent x here. And also e raised to a natural log of x would just be equal to x, the argument in the exponent. So let's take this property and walk through an example together. Let's say you're asked to simplify the natural log of e to a power of -6 plus e to a power of a natural log of 12. Step 1, replace the logarithmic term here with the value of the exponent, which would be -6. The natural log and the e cancel out, leaving us with -6. And now for the second term, we want to replace the exponential term with the value of the argument of the exponent. So this e and the natural log cancel out, leaving us with the term inside of the parentheses, which is 12. So we wind up with -6 plus 12. And once we evaluate this, we see that -6 plus 12 is equal to +6. So this is how we would go about using the inverse rule to simplify natural logs. Let's now have you try a few practice questions. Simplify question number 1. -2 times the natural log of e to a power of 3 plus e to a power of natural log of 9. Question number 2. 4 times the natural log of 1 divided by e to a power of 12. And question number 3, the natural log of e to a power of 3 to a power of 4 divided by e raised to a power of a natural log of 2 to a power of 5. Pause the video, answer these questions, and then press play when you are ready to begin. Question number 1, we want to simplify -2 times the natural log of e to a power of 3 plus e raised to a power of the natural log of 9. So step 1, replace this logarithmic term here with the value of the exponent 3. That would leave us with -2 times 3. And now the second term, e to a power of a natural log of 9. We want to replace the exponential term with the value of the argument, which is 9. And now we want to evaluate. And -2 times 3 would give us -6. And -6 plus 9 is equal to +3. So we find that -2 times the natural log of e raised to a power of 3 plus e raised to a power of the natural log of 9 is equal to 3. And that is the answer to question number 1. Let's now have a look at question number 2. We want to simplify 4 times the natural log of 1 divided by e to a power of 12. So we first want to change this argument so that the base is just e. So step 1, we want to make the exponent of the argument negative. So we'll change +12 to -12, which will allow us to move this term to the numerator, making it e to a power of -12 over 1, which is just e raised to a power of -12. And now these will cancel each other out. So step 2, replace the logarithmic term with the value of the exponent, -12. So that would leave us with 4 times -12. And now we can evaluate this. 4 times -12 would give us -48. So we can simplify 4 times the natural log of 1 divided by e to a power of 12 to -48. So that is the answer to question number 2. Let's now have a look at question number 3. We want to simplify the natural log of e to a power of 3 to a power of 4 divided by e to a power of a natural log of 2 to a power of 5. So we'll start in the numerator. Step 1, replace the logarithmic term here with the value of the exponent, which is 3. So we wind up with 3 to a power of 4 in the numerator. And now in the denominator, we want to replace the exponential term here with the value of the argument in the exponent, which is 2. So we wind up with 2 to a power of 5 in the denominator. And now we can evaluate this expression. So we get 3 to a power of 4 in the numerator, which gives us 81, and 2 to a power of 5, which is 32 in the denominator. So the answer to question number 3 is 81 over 32.